Okay, so what we're doing today is page 451. We're doing 12 through 20 even and 24 through 28 even. What your objective, or what you're going to need to do on each problem is, number one, you're going to have to identify what it is. You're going to tell me, is it a parabola, is it an ellipse, is it a hyperbola, or is it a circle? You're going to make sure it's written in correct standard form. And third, you're going to graph it. So I wrote down some little tricks that can help you remember when it's a parabola. If it's a parabola, only one variable is squared. And those are the standard forms of the equations, which really, if you're used to your parabolas, you don't need to write that down. You know that's the form you need to get into. Circle, both variables are squared, but they're in addition. The coefficients are the same, and that's the standard form of a circle. An ellipse, both variables are squared. It's in addition. The coefficients are different. And it's like the hyperbola that we did Friday, except it's got a plus sign in between. So you know that's the correct standard form. And then the hyperbola, both variables are squared, they're in subtraction, and they have to be equal to 1 to be in correct standard form. So as soon as we get those, we'll start with our examples that you're going to do. And again, you're doing just that even group of problems, but the key thing is you have to be able to write them in correct standard form in order to go from there. I'm not doing anything yet. All I'm doing is writing down my next example. Yes, ma'am.
Wednesday, they'll ban in Ohio, will be gone.
How many students in here are going to be gone? You guys have a good band. I listened to you Friday at the game. So, let's see. We're doing 462. I'll see if I can have some notes made. Which it is just review. So that's a good day to miss. So it's everything you've already done up to here, just on those pages. I'll make sure I have it written down for you so you have those assignments. So as everybody's getting things written down, Robert, what do you think example 1 is?
Ellipse.
Good job. Why is it ellipse?
Because you're adding.
It's in addition. Both variables are squared. Good. And that's all you needed to know. So he's correct. It is an ellipse. Both variables are squared. It's in addition, and the coefficients are different. Okay? Now, is it in correct standard form?
No.
Okay, so Nathan, what would you do to get it in correct standard form?
You divide both sides by 8.
That is good.
Yes, this is how you calculate it all.
Excuse me, Nicholas?
Quickly, so I'm just about to get that right. You know?
Good. You're about in the right location then. Because right now we're just pretty much talking. Now, Aaron, how do I sketch a picture? Now, I'm not asking you to name the major parts, the vertices, the major, the minor. We're going to talk more of that on Wednesday, because you've been doing that, right? Now we're just getting where you can identify it, write it in correct form, and then sketch a picture. You should be able to sketch a picture simply by looking at the equation. So, in order to sketch that picture, Aaron, what is the center of that ellipse?
0, 0, so the origin.
Now, remember I had a trick for hyperbolas where you took the square root of the number on the bottom to go left or right or up or down? The same thing with the ellipse. So what's the square root of 2?
1.
1
something.
1 something. That's what I need to hear. 1 something. So somewhere here. What's the square root of 4?
2.
2. So we're going to go 2 north and south.
Wait, how do you do that?
You took the square root of the 2, which is 1.4, east and west, just like with the hyperbola from Friday, Ellipse, you go the square root of 4 for the y, so that's 2 north and south, and that's your ellipse. So everybody got that? So basically, 3 things, and what did we not write up here? Ellipse. I want to see the name, the correct standard form, and the graph. So 3 things on every problem are going to be required. Yes, Nicholas?
How do we figure out was it a let?
By reading this right here, it said both variables are squared in addition and the coefficients are different. Were both variables squared? Look at your x and y, are they squared?
Yes.
Are they in addition?
Yeah.
Are the coefficients different?
Yeah.
That's how we know it's an ellipse. So you follow those rules on each one of those categories. And that tells you how to identify what it is. Now everybody has this written so I can erase, because I need more room for the next ones.
Well, we're not solving them right now.
You're doing 3 things. What 3 things are you doing?
We're just-
Naming it, get it in correct standard form, and then graphing it.
But it's, I thought that was a sketch.
What?
I thought that was a sketch.
That's the sketch right there, yes.
I thought you wanted us to like graph it the full way, that's why.
Do what?
I thought we were gonna graph it the full way, that's why I was confused.
No, we're just graphing the easy way.
We're just sketching it.
We're sketching a graph up.
Okay.
Now, next, what is this? We're ready for Dylan, I think. Are both variables squared? That's the first thing I check.
Yes.
Are they in addition? Are the coefficients different or are they the same? So that should narrow down what it is. What is it?
Circle.
Circle's correct. I'm gonna say it's a circle. Is it in correct standard form, Nicholas?
It's not.
It's not, because you got more than one x and more than one y, isn't that correct? Don't you have to have just one of each? So we need to group our x's together. What's that process we're gonna be doing? And group our y's together.
It's not like called difference of squares.
Complete the square, that's the process, that's right. Okay, so let's see, Spencer, why don't you tell me what's half of 16 squared?
64.
So we're gonna add 64, so what do I do on the other side?
Add 64.
Good. Okay, and let's see, Josie, what's half of 4? I was telling the answer.
2,
And if you square it, what do you get?
4, and I on the other side.
Right, so sometimes I like to underline mine. That way I've known I've done it to both sides. Okay, now, how do I factor that? Adeline, am I saying that right yet?
Anduin,
Andel. Okay,
it would be x minus 8 squared plus y plus 2 squared.
equals, what's that add up to be?
7.
70 is correct. And I know you can name the major parts and the radius and do all the stuff that we've done normally, but right now we're doing 3 things. We're gonna do all of that come Wednesday again. So we're just kinda getting bits and pieces of it all put together. Okay, so now, how do I graph that? In order to graph, you gotta know what the center is. So what is our center, Tatum?
Would it be 8, -2?
It would, change, you change both of them. So, and you can say that if it helps you. So I'm gonna go over 8 and down 2. Now, how did we graph that circle with just a sketch? What do you have to know in addition?
The radius.
You need to know the radius, good job Nathan. So, Mary Lynn, what's the square root of 70? Approximately, since it doesn't come out nicely. That's close to 64, right? What's the square root of 64?
8.
So that's a little bit more, so it's gonna be 8 something, right? So what do I wanna do with the circle? Isn't the definition of circle, set of points in a plane, equal distance from a given point? So it means I wanna go a little bit more than 8, north, south, east, and,
What?
so it's almost like our ellipse. only the ellipse, you went different north and south and different east and west. On a circle, you do the same. So we're gonna go a little bit more than 8, so somewhere in here. And again, you can use graph paper, you can do little T-graphs like I do. And your sketch really tells me everything I need to know about circle. I see the major parts in it. Yes, Nicholas?
How come we didn't go like 8 out?
We did.
Oh, it is up to 8?
Yep. We're down 2, remember, so we went 2 this way, 6, and a little bit past.
Oh, I can't read it out. Sorry.
Okay, another example. That was example 2. I labeled it wrong.
Do we need to label the radius at all?
Nope, I see it in your sketch.
Okay.
If you've done things right, won't I see it there?
Yep.
Yeah, because I'm gonna have to see if you moved the right amount, north, south, east, and west when I grade them. Example 3. I think we're ready for Riley, is that right? So everybody should be looking at it, and already be narrowing down what you think. And what's the key thing you look for when you're making a comparison? Are the variables squared? Are they both squared? So what do you think this one's gonna be, Riley? It's gonna be a parabola, because only one variable squared, the x is, right? Okay, so we're gonna say it's a parabola. Is it in correct general form? Doesn't a parabola have to be either y equal or x equal? So what's wrong with it? So what do I gotta do to get it where it's a y equal? Divide by 8. So I think I'll write it down again so I can show my work. Work is always important, so that everybody understands it. So that, what's in front of nothing's there? What coefficient is there?
1.
So that's 1/8. And what's 16 divided by 8? 2. Yes, sir.
Can we write it like just like x minus 2 quantity squared and with that divided by 8? Can we do that?
Yeah, you can write it that way, as long as you understand that it's 1/8.
Yeah.
Which that's very important when we start doing the focus and the directories, which we'll reiterate again on Wednesday, how you did your focus and directories. Right now, we're just getting a sketch of it. To sketch a parabola, the one thing you need to know is the vertex, which defines the vertex isn't that where you change and you keep? Change and keep. So if I change, what's this gonna be? 2, and then you're gonna keep the one that follows it. Now, to graph a parabola, you gotta know 2 things. The vertex, is it up, down, left, or right? You pay attention to it's a y equal. Since it's a y equal, it's gonna be up because it's a positive 1/8. And isn't it gonna be a wide parabola? Because that's less than 1? That's all we gotta do. So, over 2, up 2, it's gonna be wide, and it's gonna be going up. So all you gotta do is get me the idea of what it looks like. A sketch of it.
So it doesn't have to be exactly right.
That's right. When I say sketch, that's what I mean. I wanna see the basics of it. Now, if we wanted to, we could put in our length of the lattice. We could also find the foci, we can find the directories, but we're saving all that. Yes?
Will it need to like put the axis of symmetry in the middle or anything?
Nope. All I want is 3 things today.
Okay.
If we're doing all that, how long do you think this assignment would take?
I just knew like that Mr. Schenker was like this slope, a dotted line through the middle of it. That's all I was asking.
We're gonna do that Wednesday.
Okay.
We're gonna put all that back in there again. Example 4. Okay, I've got where it left off. Am I back to Robert? Yeah, okay, Robert, what is it?
It is a
Hyperbole, why?
Because coefficients are squared and subtracted.
The variables are squared and it's in subtraction, so that is correct, okay. Nathan, is it in correct general form?
No.
Why not?
We need the constant on the right side would be 1.
That is correct, so we want to divide everything by,
16.
so it's x minus 2 quantity squared over 1 minus y plus 1 quantity squared over 4 equals 1. Now, didn't we just do this Friday? So what did we have to know in order to graph them Friday? We needed to know the center, right? So, let's see, Aaron, what would that center be? Change.
Okay, 2, -1.
Right. Okay, so we're gonna find 2, -1. And now, wasn't it like graphing the ellipse? Except did we do different? Instead of making it of the oval shape, what did we do? We made a rectangle, right? There's the dashed line rectangle, okay, because we're working with asymptotes. Okay, so let's see, Dylan, how much do I need to move in the x direction?
1,
Mhm. How much do I need to move in the y direction?
2.
2. Now, we make a rectangle, but it's a dashed box rectangle, and this is where I use my different colors, because sometimes I've got to bring more of my different colors from home, so. And the diagonals are dashed because they're the asymptotes. What I'm trying to get you used to doing is, if you do things right when it comes test time, if you can do your conic sections by identifying it, getting a correct general form, and sketching a picture, then when you do the major parts, you'll check it. Your major part should end up lying in that part, and you'll know if your problem's correct once you're finished with it. You won't need to ask me or anything, because it's a test you wouldn't be asking me anyway. But since x comes first, which way is this hyperbola gonna lie? It's gonna be left and right, or east and west, whichever you prefer. Okay, you ready for another one? Instead of doing another one, I think what I'm gonna do is I want you to get your books open now. 12, you're actually just doing what, a few problems? Even. 12, 14, 16, 18, 20, and then you're doing 24, 26, and 28. But each problem's gonna be worth 3 points, because you gotta tell me the name of it, what it is, you gotta get it in correct standard form, and then you gotta sketch a picture, and the key emphasis is on sketching. So I want you guys to look through the problems, and we're gonna pick one of them to do together, to get you started.